Let's do a second video on collisions in two dimensions. What we have here is a cart with a certain mass and a certain initial horizontal velocity, and from above, a bag is falling down. Maybe it's got sand in it or something, and it's going to land on this cart as the cart goes past. And what we want is the final velocity of this cart bag system. So let's circle the correct answers here, and then we'll actually do the problem. Since we want the final velocity of the cart bag system, the floor, therefore, is not a part of the system. This means that any force exerted on the floor by the cart or by the cart on the floor reaches outside the system and therefore is not relevant to the analysis. These outside reaching forces act in the y direction. Thus, in this case, momentum will be conserved in only the x direction. To be clear, there are forces acting in the direction of momentum conservation. That is, there are forces that act in the x direction, but these will be internal forces for the cart bag system. Momentum is going to be conserved in the x direction. So let's find the initial momentum in the x direction. That is due entirely to this moving cart. So we have the mass of the cart, velocity, we'll say that's positive, 24 kilogram meters per second, and that is the momentum to the right. At the end, this bag has landed on the cart, and so the total mass is going to be the sum of these, 2 plus 6, so that's 8. And this cart and bag system are going to continue proceeding to the right with some x velocity. I'll call it Vx final. Since momentum is conserved in the x direction, that momentum there must be numerically equal to that momentum right there, which means the final velocity in the x direction, which is the only velocity because given the constraints of the problem, we're on a horizontal surface. So the only velocity we can have at the end is going to be in the x direction, and that's going to be 3 meters per second to the right. We chose to the right to be positive. Now, there is a force interaction that occurs between the bag and the cart. There's one in the y direction, and there's one in the x direction. Let's deal with the one in the x direction. This bag was going straight down, and after the collision, it's moving to the right. So the force from the cart on the bag is exerted to the right. Newton's third law says that there must therefore be a force from the bag on the cart, and that must be equal and opposite to the force from the cart on the bag. And look what that means. That means that the bag is going to start moving to the right because it feels that force, and the cart is going to slow down because it was moving to the right and now it experiences a force to the left, so it should slow down, and it does. It was going 4 meters per second to the right, and now it's only going 3.